Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am dealing with wave mechanics for chemistry. This is lecture number 11 in this series and I will explain you again what is Hermitian operator. In previous lecture I tried to explain it, but because of the time constraint I could not explain it properly, but now I'll try again. That Hermitian operator is such that operator which obeys the eigenvalue equation that is, if we write A psi is equal to lambda psi, okay, then operator A is said to be Hermitian if it satisfies the following condition. Now see what is the condition. That integration of psi 1 conjugate into A operator multiplied by psi 2, this is another function, dt is equal to integration bracket A psi 1 conjugate into psi 2 dt. That means you can allow multiplication of operator A with either psi 1 or psi 2, where psi 1 and psi 2 are any two eigenfunctions of the operator A. So this is about Hermitian operator. Okay. Now we will deal with significance of psi and psi square. Psi. What is this? Well, psi is as such a wave or amplitude of the matter. We know that it is amplitude of the matter wave. Or it is also known as wave function. But what does it mean? Well, it has no physical meaning. Why? Because it is only a Greek alphabet and therefore it has no physical meaning. Okay. what we know about this, it is a wave of probability of non-physical character. So it is a wave of probability of non-physical character, and it is absolutely meaningless. The symbol psi is usually used to denote the wave function of an electron, and very often psi contains the imaginary quantity I. Okay, so psi is basically A plus IB. Suppose we write like this, where A and B are functions, but what is I? I is equal to under root minus 1, and this is imaginary value. It is absolutely in imaginary value, and therefore we can say that psi must be imaginary, or psi may be imaginary. It is not real, it is imaginary. Okay, it is just imagination, that's it, nothing else. So as such, there is no physical interpretation of psi. So there is no physical interpretation of psi. Okay, it is just a symbol which indicate wave function of electron. That's it. Okay, and psi in a particle wave cannot have a direct experimental physical significance. Okay, so psi has no direct experimental significance. So this way we do not understand anything from this symbol psi. So for a quantum mechanical particle, uncertainty relation prohibits determination of the position and velocity accurately. And we know that according to Heisenberg's uncertainty principle, we so for small microscopic particle, or they are called corpuscles. Corpuscles means electrons, protons, etc. These are very, very small particles, and we cannot find out accurate position and velocity simultaneously. So this is the interpretation of psi. We don't know anything. The state of particle has therefore to be defined not by its position but by its mathematical function psi. Then what to do with this? We want a real value because we want to find out position of electron or velocity of electron, one of this. Okay, so psi may give us position of electron in 3 dimension because psi is dependent. In psi is dependent, and it is depending on x, y, z coordinates. We want to find out exact or probability of location of electron in 3 dimension, and that is why people thought that why can't we take another function which can give us certain idea. So if psi is equal to a plus iv, where I is equal to under root minus 1, then we can take its complex conjugate psi star. So psi star is known as complex conjugate of psi, and it will be a minus ib. So this is complex conjugate of psi. Okay. So if we take psi and psi star in multiplication, these two functions, when we are multiplying this, it will be a plus ib into a minus ib, and we write for this psi square is equal to a square plus b square, and there is no imaginary value I in this, so this must be real. So psi square may be real, so always represent a real quantity. So this represent always a real quantity, and therefore we can interpret psi square. Okay, so in the classical sense, the square of the amplitude at any point in space is a measure of the energy density at that point. So it is basically energy density at that point. Energy density at that point. So it is possible to interpret psi square. Why? Because it is real. So psi square is continuous and smoothly varying function. Whereas energy is discontinuous in nature. So to get this difficulty, Schrodinger suggested that psi square at any point may be taken as the probability density. So according to Schrodinger, psi square at any point may be taken as the probability density or probability per unit space for finding a photon at that point or for finding electron at that point. So this way we can interpret psi square. So psi square is real, but psi is imaginary. According to Max Born, the psi square represents the probability density for finding the particle at any point in space. And that is why, according to Max Born, psi square means probability of finding electron in 3 dimension, and that is nothing but orbital. So psi square means orbital. It is a space around nucleus in which we find electron. So this is basically orbital, and we know that there are various types of orbital: S, T, D and F. So this type of concept arised because of the Schrodinger's wave equation, and now we come to know about probability of finding electron, which can be given by psi square, and that is nothing but concept of orbital. Okay, so the concept of orbital arises here. Thank you so much.